Let's continue with the assessment of force patterns for the clip insertion job. The previous exercise we conducted a MODAPS analysis, and I shared with you this special sheet that facilitates the recording of forces for each MODAPS element. So that's why we don't have the movements and the terminal elements on the same line. And we'll see why that becomes more important as we conduct our force analysis. Just as a side issue, and maybe add a note about the previous part of this exercise where we did the MODAPS analysis, according to this, the time required to complete one cycle of this job would be on the order of 27 mods or 3.5 seconds. If you go back and look at the video of this, you'll find the time's actually longer than that. And I would encourage you to look at the job closely and try to understand where the differences are. And this is something where methods engineers really earn their bread and butter, because it's easy to oversimplify the job when you do a MODAPS analysis. So take a look at the jobs, and if you see extra motions, you want to examine that carefully and see whether those motions are actually required or whether there's something that can be controlled through the presentation materials or the training of the worker or other engineering measures. Let's talk about force. The major forceful part of this job is actually putting the clips onto the cards. So we want to basically measure the forces that this would require. And towards that end, I shared with you a video previously. We actually looked at in class last week, but I've actually added it here to the the Canvas site at the top of the page where I've been putting all the other video clips as I've produced them. And what you see here is to measure the force, we basically put the clip on the scales and then just press on the top of it to open the card, and you can see the force go up here as we do that. Now, it'll be helpful if you stop this as you get close to that, and then you can use the period and the comma key to go forward one frame at a time to see what the peak force is on this. And you can also see how it kind of builds up to a peak. And this is showing the force in grams, so it's going up like 38, 45, 40, 80, 41, 89, 4200, 4203, 42. Okay, so that goes up to about 4200 grams or 4.2 kilograms. So what I've done, and what you'll need to do, is go through and repeat this exercise so you understand what we're doing here. And then you can go to the spreadsheet, and I put your data down here somewhere, maybe towards the bottom. What you see here is I've got, there are 10 clips, so I've got them numbered 1 through 10. And here's my force recording in grams. Then I've converted it to kilograms, because quite honestly, getting these rounded off to the nearest 100 grams is plenty adequate for what we're doing here. And then my descriptive statistics are down here, so you can see the forces range here from about 3,500 to 4,600 grams, or 3.5 to 4.6 kilograms, with an average value about 4 and a 90th percentile somewhere around 4.4 kilograms, which I believe is what I told you to use for the your force calculations in this. So if we come back up here to the top now, we can come back and insert our forces. So the force here to actually get the clip is pretty insignificant. And when I say insignificant, I mean that it doesn't really require any active finger force. And the way I would measure that, and remember this as you go forward, if you can hold something in your hand, I'm sorry I don't have a camera in my hand to demonstrate this, but if I can hold something like a pencil in my fingers without actively flexing them, then I would say the force is insignificant. And you'll often find this is true for many small parts that people hold while they're transporting them. Really, the object doesn't add any significant weight to the hand. And in this case, there's a little bit of force required to kind of get the clip oriented and gain control of it, but it's pretty insignificant. And as you do that transfer from the bin to the bundle of cards, the hand doesn't really have to exert any measurable force. So for the first move to get the part, obviously there's no force because the hand is empty. and then to grasp it, again, I'd say it's insignificant. And then same thing for the left hand, it's reaching for the cards and grasping the cards, and again, the force is pretty insignificant to pick up a bundle of 4 cards. And I should have weighed the bundle of 4 cards just to give you an exact number, which I can do right now, and I can tell you the bundle of cards weigh 28 grams. So it really is not as much of a significant force here that we're talking about here. So then the next thing is to move it to the clip to the card. And again, that's going to be 0 force, and 0 force really to position it. And the same thing is true for the cards, 0 and 0. Now is where we start to see force over the right hand, because the right hand actually has to move and open the clips. So we're assuming that this force buildup starts at the beginning of that move to open the clip. So we're going to put in our 90th percentile, which we said was 4.4 kilograms, and then we hold that through the exertion. So kind of round numbers there. And then the force on the left hand is still pretty insignificant, so we'll call it 0, 0. Keep working our way down here. And for the move to set the cards aside, again, the weight of the cards plus the clip is pretty insignificant, so now the forces on the right hand are back down to 0. And that completes our force. Well, it doesn't complete our force analysis yet, because there's one more thing I want to call your attention to. Let's make these last ones 0 while the hand is waiting, left hand's waiting. So we've filled all of our cells. Another important factor that we talked about affecting strength is the posture of the hand. And in the next part of this exercise, we're going to look up relevant strength data for this, and knowing the posture is going to be quite important. So let's take a quick look at the posture here, and you can see in this middle picture on the top, and I'll maybe just let me drag this down here a little closer so you can see it. And I'm even going to blow this up a bit. Okay, so you can get a good look at that. And you can see how the individual performing this task actually is compressing those clips using their fingertips, and they're using the palmar side of their fingertips. This is what we call a palmar pinch. So I'm going to come down here where it says posture, and for the first one there's really no posture here until we get to the grasp, get the clip, and that would be I'll just say P pinch for palmar pinch. Okay, and that's distinguished from, say, a tip pinch or a lateral pinch, and we'll see examples of that in a few minutes. The left hand is reaching for the cards, no posture while you're reaching for the cards, so that's negligible. But then when it grasps the cards, it's also going to use a pulp pinch, P pinch. Okay, and then we're moving the clip to the card, and that's going to be P pinch. And then we're putting it into position, that's P pinch. These really aren't critical because we aren't really exerting significant force until we get down here to the, okay, so it's going to do it for me. Oops. P pinch. Okay, so it's not until we get down here and we begin applying the force that the posture really becomes important. P pinch, P pinch. Okay, and then moving, putting it aside, P pinch. Oops, this is the left hand, sorry, that one's, well, it's still holding it, a P pinch, because it's, well, actually no, because we put the card and it's in the process of reaching for the next one. Okay, so then, again, putting the card aside, and again, it's going to be a P pinch and P pinch. And there we have our forces. Now, what you'll find here is that it's going to start to calculate the percent MVC's force, but before it does that, we've got to come back now and determine the population that we want to use and what the strength for that population is. And once we put those values in here, it'll calculate the percent MVC, and it'll tell us what the average forces are. We'll do that in the next video.